Hello everyone, my name is Rojafari and I would like to welcome you to another video. In this video we are going to learn about Pandas DataFrame indexes, and we are going to have the focus of our video on how we would use and take advantage of this great feature of Pandas DataFrame to optimize our data pre-processing codes. And to do that, we have to learn a little bit about, a little deeper about what these indices are and how Pandas DataFrame uses them behind the scene. All right. So by the end of this video, you will have a few very powerful tricks and tools of data pre-processing that are going to optimize and improve your performance, the performance of your codes. All right. So let's get started. Okay, so like I said, we are going to focus on the indices of Pandas DataFrame, right? So that's what we're talking about. The topics that we'll be covering are put here. So if you wanna sort of like figure out one of them, if you just wanna go over one part of this video, feel free to use this part to help you guide you along with that. If you are not sort of like aware of Pandas DataFrame, if you don't have a good grasp of it, the 3 videos that can help you a lot in that respect are here: Introduction to Pandas, Pandas groupby function, something that we will be using in this video, and also Pandas apply function. Alright, so we are going to be using simulated data, right? So the simulated data, you can also find how I generated this simulated data using the simulate data code that I also will put in the GitHub repository for this video, right? So you will be able to create your own. As a matter of fact, you will have to create your own because the data is rather large. Let's just go ahead and read it. You can see it takes a bit for the data to load just because the data is rather large. It has around 5.5 million rows, right? So, and if you can see, if you look at the info, you can see it's around 300 megabytes, right? And the GitHub limits is 250 megabytes, right? So it's just way bigger than the GitHub limit. So you will have to follow along with this video. You will have to first open this file and run it from the beginning all the way to the end and save the simulated data for yourself in your own local machine. And then once you do that, you will have this data to play around. So obviously, as you are creating your own simulated data that I have created here, the outputs of our analysis, our examples, will be different. However, that shouldn't matter because what we are focusing on here is the performance of our codes and how we're going to use the Pandas DataFrame indices to help us with our performance, right? So that's don't focus on the results, right? Focus on the performance. All right, so that's our data. We've got the data of number of customer visits, revenue, and profits for so many shops across the United States, across all of these states in the United States for years 2020 to 2021, 2019, for 3 years, right? And that's a pretty big data. We've also got that date. It's a daily number of visits, revenue, and profit, right? So that's our data. And now let's use this data to understand a few stuff. First, we have to understand that for Pandas DataFrame, every row and every column are Pandas series, right? I'm pretty sure you are familiar with the fact that every row is a Pandas series. You may not have been familiar with the fact that every Pandas column is also a series, and that's very important to understand, right? So let's just check how that looks like, right? So for instance, if you look at one row, right? So the first row, right? So this is the first row of our data. You can look at the numbers, right? This is the first row of our data, and that's a Pandas series, right? You can see if you use the function type, it tells you it's a Pandas series. Pay attention to the Pandas series. The name of the series becomes the index of the row, right? So that's something that you want to pay attention to. The name of the series, the name of the row series is the index of the Pandas DataFrame, the index of the row in the Pandas DataFrame, right? So that's that. And similarly, the each column, for instance, the date column here, you can see this is the date column, right? This first column, right? This one is also a Pandas series. Of course, the series are not the same, right? They're like, they have different values and have different shapes. However, both are series. Pay attention. The name of the column becomes the name of the series. So another thing you want to pay attention here is that the columns of the data frame are the indices of the Pandas series of each row of the data frame, right? So that's one thing. The second thing, the indices of the data frame is the indices of the columns series of the data frame. The second one may be more obvious than the first one. So if I were to look at the indices here, right? If I were to say, okay, the first one, what are the indices? You will see these are the column names. And if I look at the indices here, of course, this one is more obvious. These are going to be the same indices as the data frame. Right, so this is the same indices. All right, so that's that. Now, let's learn a little bit about the two operators of .loc and .iloc. These are the operators for you to be able to grab some part of the data. And, these are very powerful and they are different, right? So we have to understand how they're different so we can fully take advantage of our Pandas data frame. So let's set our indexes, right? If we use the function setIndex, right? This is just a freshly read data, and we've got sort of like default indices here, right? But we're not stuck with them. We can set our index, right? So the function setIndex, we can set our index as state, right? So we've got to set our index as a state, right? So once I have an index other than the default index, right, then the loc operator becomes an option. I mean, if you don't have that, there is no difference between iloc and loc, right? So if you only use the default indices, right? So for instance here, if I use the default index of my data, there is no difference between loc and iloc, right? So if I put loc 0 or iloc 0, it's not gonna matter at all. It is only when I set a separate index, right? So I have a separate column as index. Now this becomes sort of like kicks the loc operators into play, right? So the difference is going to be the iloc one is just basically going to operate on the default indices, right? So it doesn't matter if you have changed indices, the iloc one basically keeps that in the background, so you can always look at each of these rows using their default indices. So that's iloc. So that's pretty easy to understand. The loc one actually has a lot of capability. For instance, as we can see, the indices, right, are not unique. We've got Alabama so many times, or I'm pretty sure every other state so many times, right? So for instance, if I say Alabama, it's going to bring out that chunk of the data. So actually I have to run this first, right? So now I've got those indices, and this is not gonna matter. The only thing that's gonna matter, the name is gonna be different. Now once I run this, it brings that big chunk of data very quickly, and all of it. Or I can bring California, so on and so forth, right? So that's that. Let's take a look at an example of how this may improve our performance, right? So for instance, our goal here is to find the revenue of shops, shop number 5 in Mississippi in this specific date. We want to do it as fast as possible. So we want to look at what we need in a very quick manner. If we want to do that, we have two ways. We've got the slow way and the fast way. So the slow way, let's first restart so that we've got the slate clean. The slow way is to basically use our typical filtering, Boolean masking, right? So we create a Boolean mask with all the specification that was specified here, right? So this is the Boolean mask for that. So we create that. And then once we've got the Boolean mask, we use it to filter our data. You can see it took 1.41 seconds to grab one row of the data. This is pretty huge amount of time to just look up one row, right? The alternative is to use the lock after setting our index. If we set our index, right, this way, by saying, okay, I've got multi-level index, right? So when you pass more than one index to your set index, you've got multi-level index, right? So if you pass that this way, your multi-level index, right, then you can use the lock operator to grab the data in a much faster way, right? So we don't need to do any Boolean masking or anything. We just call, and in matters of milliseconds, it grabs what we need to grab, right? You may say, hey, Roy, you spent a good amount of time setting these indexes, right? So it took a little bit. Let me actually also capture that using this widget time, right? So let me redo all of this so we can capture that as well, right? So this one again, 1.6, and the reindexing or setting the index took actually 2 seconds, and then this again, in milliseconds. So again, you may say, you're spending more time setting the index. Of course, yes, that's true, but that's just something we do once, right? Now, once we do this for once, and then we can keep looking at what we need to look at, right? So it does have a pretty high load cost or lead time, but once you do that, then you are golden, basically. There is another way we could have used the log function instead of just having log. We could have just add them all up in one line, right? So in one log. So let's just do that and compare their performance, right? So we could have added all of them as just one tuple. You see, just adding all of them as one tuple. Of course, we have to pay attention to the order of these indices as the way we set them. And once we run this, again, matter of milliseconds, we were able to capture it. And you can see this one is actually can become faster. This one is at microsecond, right? All right. So that's that. Let's now talk about the function swaplevel and look at an example, right? So we want to draw the line plots for profits of all the shops in California, right? So we are using here a function swaplevel. So let's see what it is first, right? So if I want to grab all the data of California, I can just use the log, right? So it has date, location as two other indices, right? You can see when I use this, the first one, now instead of having 3 level indices, now I have 2 level indices. Basically, by calling the first indices, just specific one, filtering it, now I've got 2 level indices, right? So now here, if I want to grab the data of the location, it's not possible because I have to pass through date first, right? But here I want the location, right? To do that, we can simply use the function swaplevel, swapping these levels, right? So that's basically what this is. This swaps those levels. Now we can get location and date. Now we can filter through location, as simple as that. Now that we've got that, we can have a function that goes through all of these location in the data, and for each of them draw the line plots. As simple as that. We can have this. These line plots, there are not a lot of patterns in them because these are random data, but that doesn't matter. We just wanted to showcase that how we could leverage this swap level to be able to have an easier way of filtering our data and also faster way of filtering our data. All right, so that's that. Now let's look at another example with swap level, right? So here this time we want to quickly gather a data frame that shows all of the shops at 2000, in this date, 2019-7/7. All right, so to understand this, let me set this up. So what I want here, this is actually running. Let me just kill the previous one. So this is still running. So let me kill this one. We don't need it anymore. So let's just look at the shop df, right? So here I want to data frame that shows all of the shops at 2019-7/7, right? So that's what I need. However, if I were to just use swap level, what's going to do, it's going to swap the state and location, right? If I swap one more time on top of it, it's just going to bring it back to the first one, right? It's just like nothing had happened. So it seems that this swap level doesn't let us do anything with the third level. However, that's not correct. There are a few ways we can do that. The first one is through the indices of these swap levels, right? So the first one is, this is the index of the level 1, 0, 1, 2. So if I want to swap level 2 with level 0, I just mentioned that, right? And it swaps them for me. So location is here. Or I can simply, right, use their name, right? I can simply use the name of the indices, right? So swap level, and I want to swap state and location, and it just does the same thing for me, right? So leveraging that, swapping date and state, and it doesn't matter, right? And then we can use actually wanted to filter through date, right? So we need to do this date and state, and then once we have that, then we can look up those dates, right? So that's what we wanted to learn, that we can like specify what we want to swap, right? So that's very useful. All right, so now let's look at another example. In this example, we're going to leverage group by, swap level, stack on a stack to understand that. So group by is one of the Pandas DataFrame functions that when you use it, its result comes in a data frame that has multi-level indices, right? So that's perhaps one of the first time you've come across a multi-level indexed Pandas data frame when you use group by. You may not have known, but what you would see, basically it was a multi-level Pandas DataFrame, right? So let's look at how that looks like, right? For instance, here we want to calculate and show the yearly revenue of the profit of all the shops, right? So this is what we would need to do. We have to group by based on state, location, and year, and then we want the result for revenue and profit, and we want their sum. And when we do that, then this automatically generates a data frame that has multi-level indices, right? So that's, you know, what that special look of those data frame that comes from the group by, that's what was going on. They were using multi-level indices, right? Anyway, so this is great. It's, you know, it certainly has the numbers that we want. However, it's not what we would have liked. We would have liked for year to be a part of the columns, not another row. Basically, we want the wider format of this data than this longer format. So this is the longer format. We want the wider format. One of the way we can go about this when we've got multi-level indexed data frame is using the function unstack, right? So the years have been stacked on top of each other. When we use unstack, basically we unstack the last level of our multi-level index to column. We push it to the column. So we use dot unstack. Very quickly our data shaped differently. Now we can see that you know, in every one of our shops, how we did for revenue and profit in 2019 to 2022. Sounds good? How about if we wanted to take a look at our only 2022 data, right? So we wanted to look at only the profit and 2020, right? So first we could just look at the profit, right? So this is a multi-column, multi-level columns, right? So multi-level columns. For us to grab this, we have to go through the columns one by one, right? So we go through the profit and then again 2022. So again, multi-level columns is very similar to multi-level index. Now we've got this. Now we can also use the unstack to push location to the columns again, and then we would get to this output. You may ask me, what's going on with these null values, Roy? These are because we don't have as many shops in all of the states, right? For instance, we've got more shops in Arkansas, Connecticut, and Delaware than we've got in Alaska, Arizona. That's why we've got those null values. All right, so in the last example of this video, we're going to learn how we would create a multi-level in a data frame with multi-level index, and how that could even be useful, right? So I'm going to spend a few minutes to set this up to sort of show you an example of how this could be beneficial for our data pre-processing, and then we would use this creation of multi-level index from the scratch, multi-level index and a data frame that has a multi-level index from scratch, and then you know, we would see how that is useful, right? So in this example, we're going to use a data frame that I will also upload in the GitHub repository for this video, and this one is orders.csv. So we've got 19 shops, actually 20 shops, and we've got the order quantity for each date, right, for all those shops, right? So let's go ahead and first make sure that our date is shown as the date time type, right? So now when we use pd.toDateTime, it makes sure that the date is date time. That's pretty good for our analysis, so make sure that's done. And then we can grab our unique shops, right? So these are our unique shops, like I said, 20 shops from shop 0 to shop 19. and then we can also re-index our data frame order df with shops and date, right? So that's another thing we need to do. And let's go ahead and create the line plots for each of these shops, right? So we create a loop and we want to create the line plots for each of these shops. And once we do that, we look at these sort of like trends. There is a downward trend for all of these shops, and everything looks normal. There seem to be okay. I mean, what are we talking about, Roy? It's not until we sort of like take a closer look at our data. Let's say in the shop one, in the last 20 data, we see that in our data there are some jumps in the dates, right? We don't have data for 05, the date 5th of September, or the 7th, right? Or the 12th, or the 14th. So there are a lot of jumps in the data. And we can like check with other shops, and the same thing is there as well. What's happening is, because the order quantity was 0, it was never recorded. And you know, we could sort of like have a loop to go over the data, and wherever there is a jump in the data, sort of like add a row to our table. That's going to be time consuming and computationally very expensive. However, what we can do is we can, you know, the solution is proposed here. We can create a full data frame with all the dates and all of the shops, and put all of the value as zeros, and then use the update function of the Pandas DataFrame to sort of like just update this. And that's just going to be very much faster than the alternative, going through and like adding rows when we don't find them. So we are going to do this in two different methods. The first method is using the function pd multi-index from arrays, and then we're going to do the same thing with pd multi-index dot from product, and we'll see the difference between them and how and which one is better for this situation. So for us to be able to do that, we need to have all of our values for our shops and our dates, right? So we have them for our shops. So these are all the shops values, and then for our dates we have to you know, grab the first date and last date, the minimum and the maximum, right? And between them there are 363 days, right? We use the function time delta from the date time and a list comprehension to create all of our dates, all of our possible dates, like, you know, including everything that is between the minimum and the maximum date, right? So those are our list, right? And for the using the array, the multi-index from array function, we have to simulate, we have to create our two columns as our index. And for us to be able to do that, we need to do that in two loops, right? So in a nested loop, we go through the shops, and then we go through all the dates, and we add them to first level and second level index, right? So that's what we do. And you can see in our first level index, shop 0, and then all of the dates, and then shop 1, then all of the dates, and then shop 2, then all of the dates, right? So that's how it's going to be. And then for second level, you can see that we've got the repetition of the same dates, right? You know, 1 time, 2 times, all the way to 20 times, right? So once we have that, we can use the function. We pass these first level and second level, and then we give them our name, and then we've got our index. So for the purpose of learning, let's take a look at what that is. So let's see my index, and we can see that we've got that index figured out, right? And now that we have that, then we can just pass it as my index, and my column is just going to be quantity. So this is my stage df. I'm staging this data, that's why I'm calling stage df. Everything is 0. And now all there is for me to do is to update the stage df using the order df. once I do that, this has not worked. Everything is still 0. What's going on? Here's what's going on. The stage df indices, right, are different. Right, here are shops and dates. This is the typical index. For us to use the update function, we have to make sure that the indices of our data are the same. Right, so we fix that. We set the index before passing it to the update function. Now this works. And quickly checking our data, we can see now those zeros have been plugged in automatically. And this is a very fast way of doing this, comparing to just looping through and checking and adding new rows. So in this situation, actually having used the other way to create the index would have been simpler, right? The product from product. From product, you don't need to create levels. It basically automatically does what we did in this piece of the code, right? It automatically does that, and actually does it in a much faster way, right? So it's actually better for us to do it this way, right? So we've got the products of these two lists, right? So that's what we want in this situation. So when we want that, we can just use that function, and it just gives us the same. And we can again update it, and you can see how fast this runs, right? It's very fast. And then we can now re-index our order df, and once we do that, now this order df is again ready to be creating line plots. So let's go ahead and do that. This time we're going to create both of the line plots using the order df and the stage df. The stage df is the process data that is correct with all of the zeros. Order df is the original one, right? So let's go ahead and sort of like run them and compare them. So this is the original, and this is the processed correct version of our visualization. We can see a few things. First of all, we do see more of our zeros happening, right? So these are those zeros that we didn't have here, right? So those were omitted. The second is, since all of our dates are included, the pandas plotting function does a great job of showing that this is a date. But because before it was here and there, not all of the dates were included, it didn't do this great of a job of creating that axis. All right, so a quick summary of this video. Basically in this video, we learned a few things about pandas indices and how we can leverage that to leverage the sort of like the foundation of Pandas DataFrame with the indices to improve the performance of our data pre-processing. All right, until the next video.